Okay. Here we go. So, we're going to jump into here, all right? And again, we're talking about kind of two different situations. We'll talk about events that are mutually exclusive, right? And then also events that overlap, all right? And you can kind of get an idea of what mutually exclusive means, right? Because we're comparing it to overlapping, all right? So overlapping events are events that maybe have things in common, right? So for example here, in our warm-up, right, event A, right, had 3, 6, and 9 as possibilities, okay, right? Event B had 1, 3, 5, 7, and 9, okay? So event A and event B were overlapping somewhat, right? Because what did they have in common between the two of them? Yeah, 3 and 9, right? So they were overlapping events. They were not mutually exclusive. Mutually exclusive means that, you know, the two sets would have nothing in common with one another. Okay, they are mutually exclusive. There's nothing shared between the two of them. They have all different elements between the two sets. Okay, so that's what the basic understanding is, and I'll write that down here. Okay, so two events are mutually exclusive. Okay, if they cannot both occur at the same time. Okay? So for example, right, if you flip a coin, it cannot land both heads and tails up, right? That's not possible. So let's do an example here and talk about that. Okay. And some of you will probably be happy that we're going to kind of abandon the set stuff for right now. Okay, we're just going to abandon the set stuff, but we'll bring it back in at the end here to kind of reconnect some stuff, hopefully. Okay, so let's say for our example here that we have a numbered dodecahedron. Yes, it's 12-sided. Very good. How'd you know that, Gio? Just remember it? Okay, gotcha. Yeah. Yes. So you guys remember your prefixes from geometry maybe, right? For example, like, not even, like hexagon, pentagon, heptagon, octagon, nonagon, decagon. What's that? What's that? Try something, triangle. Maybe it was, you were thinking about a different thing. Oh, I'm sorry. I misunderstood. Okay, sorry. So yeah, and then after decagon, right, you kind of stop naming the polygons after that, right? Because you're like, so you did like 11 gon or 12 gon. But there are names, okay? So actually the 11-sided polygon is a undecagon, I think. And then the 12-sided polygon is a dodecagon. Now, a dodecahedron, okay, so what's the hedron part? A hedron then is we're now talking about a three-dimensional shape, okay, that has 12 sides. So 12-sided, okay, a 12-sided die, okay, or a D12 for you D&D fans. I won't make you guys raise your hand or anything like that if you're not wanting to. But what's that? Yeah, Dungeons and Dragons, yeah. Never played before? I played like once or twice. It's interesting. Mr. Gill has a club if you guys are ever interested in trying it out. He'd be happy to show you the ropes. What's that?
Seems like a 1B.
It can be. Yeah. So it's what, like the guys in Stranger Things are playing. So anyway, a number dodecahedron, okay? So numbered 1 through 12. And you can actually buy these kind of die online. They go up to, I think D20 is what they use in Dungeons and Dragons, but you might be able to find even higher numbers of sides. Of course, the more sides you add to a die, the more it looks like a sphere. and then it kind of makes it more difficult for it to like land on a side because it keeps rolling and stuff like that.
I don't know what the most standard die is.
You can look it up, but I imagine it's, again, at some point you kind of lose the utility of it, and you just start doing like, I don't know, maybe a spinner or something like that. Or you start using combinations of die, maybe. Okay. So anyway, we have a numbered dodecahedron numbered 1 through 12. Okay, and we want to find the probability. Okay, what is the probability of rolling an even number or a 7? Okay. So what's the probability of rolling an even number or a 7? Okay. So how many events do we have here? 2 events, right? Let's just name them A and B, okay? Let's talk about event A. What is A? What is event A going to be? It doesn't really matter which one you make it, but just what do we want to make event A? That we roll a even number, sure. That's the first one. Let's go ahead and put that with A. Okay, and then event B, what are we going to say that is? Yeah, rolling a 7. So I really should put rolling an even number, and then B is rolling a 7. Okay. Also, let's just go ahead and do this too. What's our sample space here? What are all the possible outcomes that we could roll with this numbered dodecahedron? Yeah, 1 through 12, right? So 1, 2, ... 11, 12. Okay, because it's important to recognize all the possibilities too. Sorry, B is rolling a 7. A is rolling an even number. Is that what you're asking about, Mike? Okay. Okay. So, the probability of A. What's the probability of just A? What's the probability of just A here? Okay, yeah, so we got to think about how many even numbers are there from 1 through 12. So there's 2, 4, 6, 8, 10, and 12. So there's 6 even numbers on that die out of 12, or 1/2 then, right, if we simplify. Okay. What is the probability of just plain old B? So yeah, how many 7s are there on that die? 1, so it'll be 1 out of 12, which doesn't simplify. Okay. So then we want to ask, okay, what is the probability of A or B? Okay. Well, how many ways can we get A? Well, we said 6, right? And how many ways can we get B? We can get it 1 way. So what's the probability of A or B going to be there? Yeah, 7, right? There's 6 ways to get event A. There's 1 way to get event B. So it'll be 7 out of 12. Okay? And then if I do this, probability of A plus the probability of B. All right. So we did A or B. We got 7/12 there, right? Probability of A plus probability of B. Well, if I just take the probability of A, which is 6/12, and I add the 1/12 there, I get 7/12. Question?
How do you get 6/12?
For probability of A? Well, so A is rolling an even number. So if you think about it, again, we have our number dodecahedron that has all the numbers 1 through 12. So So how many even numbers are there on that die? 2, 4, 6, 8, 10, and 12. So 6 total numbers on that die will be even. 6 out of the total 12 that are on the die. Okay? So 6 out of 12 numbers are even. For B, right, well, B is just rolling a 7. Well, there's only one 7 on the die, so 1 out of those 12 sides are 7. So that's why it says 112. Okay? And then for the OR, we'll be talking about, okay, getting an A or a B. Well, to get, the A, there's 6 there, and then the B, there's 1, 7, so we add those together, you get 7 out of 12 then. And if we just add the two probabilities, then we get 7/12 as well. So in general, what I'm trying to show here, for mutually exclusive for mutually exclusive events, and we'll say A and B, the probability of A or B is just equal to the probability of A plus the probability of B. Okay? And this is one of the key takeaways right here. Okay? For mutually exclusive events, A and B, the probability of A or B is just equal to the probability of A plus the probability of B. Okay? We okay? All right. Sorry, guys. I'll open up a door here, maybe get some ventilation going. All right. Try to breathe through your mouth or something. I'm sorry. What's going in one way or the other? The best thing to understand about when your sense of smell, by the way, is that in order to smell something, you have to take very small particles of it into your nose in order to smell it. So, just so you guys know. Isn't that great? All right, so moving on. So let's talk about overlapping events.
I can't breathe. I really can't breathe.
You are a blessing in disguise.
I don't know. Sometimes you put that stuff with it, though, and it makes it worse. But take your chances, sir. Okay, so overlapping events are two events that have one or more outcomes in common. Okay? I can smell the perfume now. All right, so let's do our example here with this. We'll do the same thing. Okay, so let's say we're again, let's see here. Yeah, what is the probability that you roll a numbered dodecahedron, again 12-sided, okay, and the result is even or greater than 7. Okay, so I won't make us do the sample space again because it's the same situation. It's a dodecahedron, right? But I do want us to talk about event A and event B. What are our two events in this situation? Event A is still rolling an even number. Okay, but what is event B in this situation? What's event B in this situation? Rolling a number greater than 7. Okay. So, let's talk about the probability of A. Okay. What's the probability of just A? What's the probability of rolling an even number on that 12-sided die? If it's numbered 1 through 12? 6 out of 12 again. Yep, same thing. That because that event didn't change, right? So it's 6 out of 12 or 1/2 if you want to simplify there. Okay. What about the probability of B? In this case, what's the probability of B? How many numbers are greater than 7 on that die? So we got 8, 9, 10, 11, 12. There's actually 5, right? 5. Okay. Now, wish I had changed this, yeah. What is the probability, though, of A or B in this case? What's the probability of A or B going to be in this case? Okay, so let's think about this here. Event A, what are the possibilities we could roll? We could roll a 2, a 4, a 6, an 8, a 10, or a 12, right? For rolling a number greater than 7, we could roll an 8, a 9, a 10, 11, or a 12.
11 out of 12.
11 out of 12?
Yeah.
Okay, how'd you get that?
I added 6 over 12 and 5 over 12. I don't know if that's right.
Okay. Why do you hesitate?
No, that's right.
Oh, okay.
Yeah, because we did that last time.
We did do it last time, right? Mm-hmm.
Good job.
Funny joke. He's just JK. So, is it 11 out of 12 here? Well, let's take a look. Rolling an even number, right? You got 2, 4, 6, 8, 10, and 12 there. Rolling a number greater than 7, you got the 8, 9, 10, 11, or 12. So we've got, 1, 2, 3, 4, 5, 6 numbers here, and 1, 2, 3, 4, 5 numbers here. But what do you notice about some of the numbers in these two sets? They're the same. Should we count them twice?
Did that say 8, 9?
We shouldn't, should we? Yeah, it says 8, 9, 10, 11, 12. We should not count them twice, right? Because are there two 10s on that 12-sided number dodecahedron? Probably not, right? It's probably all 1 through 12, right? So we're going to assume not. So Cheyenne is at 11 out of 12. It's not going to be. It's going to be smaller than that, right? So let's count them up here. Well, again, we'll do the 2, 4, 6, 8, 10, 12. So there's 6 there. Okay. And then 7. And then the 11 as well. 8. Right? So it's this one, this one, this one, this one, this one, this one. And then 9 and 11 as well. And so that makes a total of 8. And so it's not 11 out of 12, it's actually 8 out of 12. Okay? So what do we have to do there? We had to eliminate the overlap. 8, 10, and 12, right? They overlapped. I don't know if I'm doing too much marking there, but anyway. 8, 10, and 12, they overlap. Okay. Which we can kind of figure that out by doing the probability of A and B happening. Okay? So let's take a look at that. What's the probability of A and B happening? So that means what's the probability of both rolling an even number and rolling a number greater than 7? Well, in how many events, how many situations there are we rolling both an even and a number greater than 7? How many of our numbers here are both even and greater than 7? How many? 3, right? 8 and 8, 10 and 10, 12 and 12. They're both, 8 and 8 are both even and greater than 7. 10 is also even and greater than 7, and 12 is both even and greater than 7. So it's 3 out of 12 there. Okay? So now if you look at what Cheyenne said earlier, right, she said 11 out of 12. Right? If we then subtract that 3 out of 12, those are all the overlapping ones, right? 11 out of 12 was like the total, 6 plus 5, 11 twelfths. Okay, that Cheyenne added together there, which makes sense, right? That's what we should be able to do here, but because we overlap, we're going to subtract the overlap, which is the and. And what's 11 take away 3? 8 out of 12, which is what we got as our actual answer there of A or B. Okay? So I'm going to have to go another sheet of paper here for this. So for overlapping events, okay, let's keep this up here. For overlapping events, A and B, we'll say. Okay. The probability of A or B is equal to the probability of A plus the probability of B, like Cheyenne did, right? Minus, though, the probability of A and B, where they overlap. Okay? And in fact, you could really use this formula for the mutually exclusive ones as well, right? You could use this same formula here for the mutually exclusive ones. Because if two events are mutually exclusive, what would be the probability that A and B both occur? If A and B are mutually exclusive, what would be the probability that they both occur at the same time? If two events are mutually exclusive, what will be the probability that they both are going to occur at the same time? Every time. It'll be what? So think about like heads and tails, right? What's the probability that you will land both a head and a tail on a coin? Exactly. It's probably 0, right? So my point is, when you have mutually exclusive events, the probability of A and B happening will be 0, and so you're just going to end up adding these two together. So you can use this formula both for the mutually exclusive and for the overlapping events. For mutually exclusive, this will be 0. For the overlapping, well, there will be situations where you'll have both happen at the same time. That's where the and will come in. Okay. So you could use that one for really for both of them if you want to. All right. Yep. All right. So let me give you guys a chance to try one or two here.
Are we done with those?
Let me see here. Let me just check to make sure. I don't want to rush off too quick here. Almost. We're close here. Yes. Yeah, we're close. We're close. I just want to do I want to do one or two more examples here. Okay, so let's just determine the probabilities using the table below. Okay. And I'll pick a smaller table here. This one's too much. Let's do this one. Okay. Yeah, no, I'll do this one. Okay. Get some more interesting stuff going on. You guys may remember these from Algebra 1. Okay, and for simplicity's sake, yes, we're just going to talk about boys and girls. I know that there are other options nowadays, but we're just going to make it easier to deal with, and I don't mean to insult anybody. All right, boy, girl, and then we'll do a total here too. And then we're going to have 9th grade, of course, 10th grade, 11th grade, and 12th grade. Okay, and then their total as well. Okay, and let's just do 98, 102, 104, 106. Okay. Remember these are called two-way tables. Okay. So again, this is just for the sake of the argument here. We have the 9th, 10th, 11th, and 12th grade classes, all right, separated into boys and girls, okay? So let's say, what's the probability? Let's just do some easy probabilities here. What's the probability of getting a 9th grade boy? Okay, if you randomly pick a student in the school, what's the probability of picking a 9th grade boy? $98 out of? Yeah. Which total are we supposed to use here? So we're saying we're going to just pick a 9th grade boy out of the entire school. So it'll be out of 808. Yeah. It's got all of the students, because 808 would be all of the students combined, right? All right. Yeah. So then how about what's the probability of just selecting a girl? What's the probability of just selecting a girl? Randomly selecting from all the students in the school, what's the probability of selecting just a girl? 412 out of 808. Exactly. Okay. What's the probability of selecting a senior or girl? Okay. So here we have this, again, this idea of, we have two events now, okay, two events. We kind of technically had two events with the 9th grade boys too, but it's 9th grade and boy kind of thing. But for senior or girl, we have two events, right? So we have probability of a senior or the probability of a girl. Are these events, being a senior and being a girl, are those events mutually exclusive or do they overlap? So so again, one more time, the event of being a senior, the event of being a girl, right? Do those two events overlap at all? Yes. Right here, right? So this probability is equal to the probability of being a senior plus the probability of being a girl minus the probability of being a senior and girl. Okay? So probability of being a senior or girl is probability of being a senior plus probability of being a girl minus probability of being a senior and a girl. Okay? Here's the idea, right? What's probability of being a senior? How many seniors are there? 202 out of 808, right? They're right here, right? These are the seniors, 94, 108, and the 202, right? But then also, we have the probability of girls. How many girls are there? 412 out of a total of how many students? 808. All right? So, we have our 12th graders here. Okay? And we have our girls here. And you'll notice that 108 gets used twice. That 108 gets used in the 12th graders, and that 108 also gets used in the girls too. So that's why we have to subtract off. Since it gets used twice, we're going to subtract off one of them, because that's also the probability of being a senior and a girl. Being a senior and girl, 108, it got used twice. So we're going to subtract it out to make the probabilities right. Okay? And so then we will get, let's see, what's that going to be? 412 minus 108 is going to be 304. 506, I believe. Oh, my calculator's in my bag. Oh, there it is. 506 divided by 808, and it's divided to 253. Okay. You also could just, for the probability of senior or girls, you could just add up this number, this number, this number, this number, this number, right? You could do 94 plus 108 plus 96 plus 106 plus 102, and then put it out of 808 that way too. Okay, your choice. Okay, but there is just an example there with a table. Right? Questions on any of that? All right. So let me get you guys started then on your assignments. Oops, that's the wrong paper. That's the wrong paper. So it's going to be out of 19-4. We skipped a couple sections. I'm going to do this out of 19-4 here. Okay. 19-4, which is on page. Starts on page 719. I'd like you to do numbers 1 through 10, let's say. Okay? Yeah. Numbers 1 through 10. All right. Please keep in mind, you might have some mutually exclusive events, and you might have some overlapping events there, so keep an eye out for that. All right. Yes. Okay. Actually, can you hold on for 1 sec, Mike? I just want to show you here.